Hello dear students, welcome back to your channel. I love pharmacology. So in today's session you are going to learn about one of the very important concept under general pharmacology. So are you able to make out to which of this option does this image belong to? So as you can see that x-axis has been represented by percentage of maximal response, that is the efficacy, whereas the y-axis has been represented by the agonist dose, which represents the potency. So when you give a agonist alone, you can see the response. This is the dose response curve. So following the administration of antagonist along with the agonist, you are seeing the response, that is in the red curve. So here you can see the efficacy, what is happening with the initial dose with agonist alone, as well as subsequently there is a decrease in the efficacy. But what happens to the potency? Potency remains same. Potency is same, but the efficacy has been decreased. So already in the previous video we had discussed about, so if there is a parallel rightward shift, that means to say the efficacy will remain same but the potency will decrease. In which type of antagonism? In case of competitive type of antagonism. So now you have ruled out the competitive antagonist. So agonist is the one which has to produce a maximal response. So it has been ruled out again. So the remaining is, it is the non-competitive antagonist. So this image represents the example for non-competitive antagonist, where you can see that, so whenever you use an antagonist along with the agonist, if the antagonist is non-competitive in nature, you will not be able to overcome the antagonistic activity by increasing the dose of the agonist in case of non-competitive antagonism. So that's why the response has been decreased. So the efficacy has decreased. So please remember, so this image is the classical example for the non-competitive type of antagonism. So here you can see that agonist will have both higher affinity as well as higher intrinsic activity. Affinity means the ability to bind. Higher intrinsic activity means ability to produce the response. So usually the agonist will trigger the maximal response. It usually mimics the effect of endogenous substances. So one such example is the methacholine, which is a cholinomimetic agent which produces the response similar to that of the acetylcholine by binding to the cholinergic receptors. Whereas competitive antagonist, you can see that the dose response curve will shift towards right. It is called as parallel right shift. The efficacy remains same but the potency will decrease. Whereas in case of the non-competitive type of antagonism, the dose response curve will shift downwards. The efficacy will decrease. Please remember, efficacy will decrease in non-competitive antagonism but the potency will remain same. So this was about the class on the important concept, that is non-competitive antagonism. So if you get this image, please remember it is an example for non-competitive type of antagonism. So if you find this video useful, please do subscribe to my channel. I love pharmacology, and do not forget to share and hit the like button for more updates on pharmacology. Thank you.